Hello everyone, I am Dr. Aras Patel from LG Institute of Applied Sciences. Today I will discuss on Electrochemistry Unit 2 Paper 303 Physical Chemistry of Semester 5 as per Gujarat University syllabus. This is third video of Electrochemistry. In this video I will discuss on reference electrode. There are main three types of reference electrode. First one is standard hydrogen electrode, second is Calomel electrode and third one is Quinhydrone electrode. Let us discuss on first reference electrode, that is standard hydrogen electrode. First electrode is SHE, that means standard hydrogen electrode. Why do we call standard hydrogen electrode? This electrode is made up of hydrogen gas and it is used in standard condition. That means 1 molar concentration of this experimental solution and 1 atmospheric pressure of this hydrogen gas, and this electrode is used in 25 degrees Celsius or 298 Kelvin temperature. Now we discuss simple construction of standard hydrogen electrode. This platinized platinum foil is joined with platinum wire and dipped into the experimental solution containing H plus ion, and its concentration must be 1 molar. And hydrogen gas is passed in this electrode at 1 atmospheric pressure. And this hydrogen is adsorbed on platinized platinum foil, and oxidation and reduction reaction is take place. So cell reaction is oxidation cell reaction, that means H2 gas, it gives 2H plus 2 electron and its EMF value is 0.0 volt. And the reduction half cell reaction is 2H plus getting 2 electron and it gives H2 gas and its EMF value is equal to 0.0 volt. And the cell representation of standard hydrogen electrode is H plus in bracket 1 molar oblique H2 gas oblique platinum solid. Here oblique is indicated in contact with. That means experimental solution containing H plus and its concentration is 1 molar is in contact with H2 gas, and this H2 gas is in contact with platinum foil. And the absolute EMF of the standard hydrogen electrode is 4.44 plus or minus 0.2 volt, and the EMF of the standard hydrogen electrode is taken as 0.0 volt. Now I am referring from this side. The standard hydrogen electrode is used for determining the EMF of the other electrode, and the electrode potential E H plus oblique H2 is equal to minus 0.0591 into pH. So in this case the potential of this hydrogen electrode is depend on pH of the solution. And there are some drawbacks of standard hydrogen electrode. The first one is it is difficult to get pure and dry hydrogen. That means sometimes hydrogen involve impurity and moisture. And second drawback is hydrogen gas cannot be maintained at 1 atmospheric pressure for longer time. That means if hydrogen gas is not maintained at 1 atmospheric pressure, then EMF of the standard hydrogen cell will be disturbed. And third drawback is concentration of H plus cannot be maintained at 1 molar. That means HCl being a gaseous form and it evaporate from the solution. That means concentration of the solution will be changed, then the EMF of the standard hydrogen electrode will be disturbed. Due to this drawback of standard hydrogen electrode, it is used as primary reference electrode. Now second reference electrode is Calomel electrode. It is simple construction of Calomel electrode. The platinum wire is dipped in solid mercury and paste of Hg2Cl2 and Hg, and the Hg2Cl2 is in contact with saturated KCl solution, and finally this electrode is in contact with experimental solution. In this case Hg solid is oxidized into Hg plus and release electron. Electron is moved to the cathode wire. Here Hg plus will attract toward the Cl minus and it is converted into Hg2Cl2, that means mercurous chloride, and that's called Calomel. So we call Calomel electrode. And the cell reaction of Calomel electrode is Hg2Cl2 solid plus getting 2 electron, it gives 2 Hg plus 2 Cl minus. And from this reaction we get equation of cell potential. E cell is equal to E0 cell minus 0.0591 into log concentration of Cl minus. And from this equation, we say that the EMF of the cell is depend on concentration of KCl solution. For example, concentration is 0.1 normal, then EMF of the Calomel electrode is 0.338 volt. If concentration is 1 normal, then EMF of the cell is 0.280 volt. And as it is, if solution is saturated KCl, then EMF of the cell is 240 volt. If we use saturated KCl solution in Calomel electrode, then it's called saturated Calomel electrode, and it is secondary standard electrode. And the cell representation is Hg oblique Hg2Cl2 in solid form and oblique KCl saturated. And the Calomel electrode is used in pH determination and polarography. Now third electrode is Quinhydrone. Here platinum wire is dipped in Quinhydrone, the solution containing H plus ion. Here the paste of Quinhydrone, that is equal molar mixture of hydroquinone and quinone. There are two possibilities. First one is in basic condition, the oxidation reaction is take place and this electrode is act as anode part. In this case, hydroquinone is oxidized into quinone, which releasing 2H plus 2 electron. As it is in second condition, if solution is acidic, then the reduction is take place and its electrode is act as cathode part and quinone is reduced into hydroquinone. And we also write H2Q is in equilibrium with Q plus 2H plus 2 electron. That means Q, that means quinone, and H2Q, that means hydroquinone, that means 2H is attached to this oxygen. And the cell reaction is Q plus 2H plus getting 2 electron and it is gives H2Q. And from this reaction, the cell potential is E is equal to E0 minus 0.0591 upon 2 into log 1 upon H plus square. And E is equal to E0 minus 0.0591 into log pH, and pH is equal to minus log H plus. The cell representation of Quinhydrone electrode is platinum oblique Q, H2Q oblique H plus in aqueous form. Now, and E cell is equal to E cathode minus E anode. Here, hydroquinone electrode is act as cathode part and Calomel electrode is act as anode part. And from this equation, we determine the pH is equal to 0.457 minus E cell upon 0.0591. And from this equation, we also determine the concentration of any acid solution or base solution. And there are advantages and disadvantages of Quinhydrone electrode. First one is it is very simple electrode. Second is presence of oxidizing agent does not affect the equilibrium. Third one it is free of salt error. And fourth one is it has low internal resistance power. And last one is it is attain the equilibrium very rapidly. And there are some disadvantages of Quinhydrone electrode. First one is it alters the equilibrium between quinone and hydroquinone. So it is useful for solution up to 8.5 pH. Second is it is not used for substance like Fe plus 2, MnO2, etc. And third one is it is not stable for long time, particularly above 30 degrees Celsius temperature. Thank you.